The question here says that a river is 2.5 kilometers wide and flow at 3 kilometers per hour. A swimmer who can swim at 5 kilometers per hour in still water wants to cross to a point directly opposite the starting point. The question is, in what direction, relative to the straight across line, should he head? Alright, let's provide a visual to this. So we have a river. This is the river, and the river is 2.5 kilometers wide. 2.5 kilometers. Now let's say that this river is flowing to the right. This is the direction of flow, and we are given that the speed is 3 kilometers per hour. That is the speed of the river. A swimmer who can swim at 5 kilometers per hour. So speed of swimmer is 5 kilometers per hour. Wants to cross to a point directly opposite the starting point. If we choose this point as the starting point, that means he wants to go from this place straight across to this point B. So he wants to stop here. Now the question is, in what direction should he head? We know that he cannot just swim straight across. Why? Because if he swims straight across, it's not going to end at point B, because the river is pushing him to the right. So if he's swimming straight across, he will most likely going to end at this point. So this is not going to be correct for him. Swimming straight across will not make him to end straight across or straight at the starting point. That means the best possible thing to do is to swim in this direction if you take the river to be swimming or to be flowing to the right. So it's going to swim in this direction so that the push of the river can land him here. Now what we have is a right angle triangle, which I'm going to extract and put here. So this is the hypotenuse, and that is the speed of the swimmer. So this is 5 kilometers per hour. We have this as one leg, which is 3 kilometers per hour, the speed of the river. And this actually will be the effective speed that is taking the swimmer to opposite side. So this is unknown, and we can find it using Pythagorean theorem. Already we have 3, 4, 5 triangles, so you should know that this is equal to 4. But let's use Pythagorean theorem to confirm. So using Pythagorean theorem, we have 5 squared equal 3 squared plus x squared. So x is going to equal 25 minus 9 all into square roots. So x is equal to square root of 16, which is 4. Which means that the effective speed which takes the swimmer across is 4 kilometers per hour. But the first question says that in what direction should he head? That means he must be swimming at an angle. So in what direction means we should look for that angle in which he's swimming. We have this angle here to be unknown. So we can use tan theta is equal to opposite over adjacent. The opposite side is 3. The adjacent is 4. Tan theta is going to equal tan inverse of 3 over 4. So put that in your calculator. What is tan inverse of 3 over 4? Tan 3 over 4 is 36.9 degrees. So which means that the direction it should be heading is 36.9 degrees relative to the straight line across. The second question is, what time will it take him to cross the river? So we are looking for time. We know that the effective speed that took him across is 4 kilometers per hour. So this is the perpendicular speed relative to the ground. So the speed relative to the ground is 4 kilometers per hour. That is the speed we are going to use. That is the speed, the effective speed relative to the ground that took him across. And we know that the distance is 2.5 kilometers. That means we can say that V is S over T, then T will be the distance over the velocity, which is 2.5 over 4. 2.5 over 4 is equal to 0.625 hour, and we can convert that to minutes by multiplying it by 60. That is equal to 37.5 minutes. So the time it's going to take him is 37.5 minutes.